and Assalamu alaikum. Today, our first chapter is periodic classification of elements and periodicity. In this chapter, you will learn number one to describe the periodic table in terms of groups and periods. Number two, describe and explain the periodicity in physical and chemical properties. To describe the position of hydrogen in the periodic table. Introduction. To achieve a thorough understanding of a complex subject like chemistry, it would be highly desirable to fit all the facts into a simple logical pattern. The periodic table of elements has served the purpose to systemize the properties of the elements for well over 100 years. The development of periodic table is one of the most significant achievements in the history of chemical sciences. The periodic table provides a basic framework to study the periodic behavior of physical and chemical properties of elements as well as their compounds. In previous classes, we have learnt about the periodic classification of elements. In this chapter, in more detail, the periodic table and the periodicity of the elements will be discussed. Historical background. The early history of ideas leading up to the period classification of elements is fascinating, but will not be treated in detail. Those who made memorable contributions in this field are Al-Razi, Dobrinier, Newland, and Mendeleev. Al-Razi's classification was based on the physical and chemical properties of substances. Dobrinier, a German scientist in 1829, arranged the known elements in a group called triads, as each contained three elements with similar properties. Newland, who was an English chemist, in 1864 classified 62 elements known at that time, in increasing order of their atomic masses. He noticed that every eighth element had some properties in common with the first one. The principle on which the classification was based on was called the law of octaves. In 1871, a Russian chemist, Dmitry Mendeleev, gave a more useful and comprehensive scheme for the classification of elements. He presented the first regular periodic table, in which elements of similar chemical properties were arranged in eight vertical columns called the groups. The horizontal rows of the table were called periods. Mendeleev also started by arranging the elements in ascending order of their atomic masses and found that the elements have similar chemical properties appeared at the regular intervals. This significant observation was called periodic law. Mendel left some gaps in his table for elements which had not yet been discovered, and by considering their positions in the periodic table, he predicted properties of these elements. For example, germanium was not at that time known, but Mendeleev was confident that this element must exist, so he predicted its properties. A few years later, germanium was indeed discovered, and a remarkable agreement was found with Mendeleev's predictions. 1.1.2 Improvement in Mendeleev's periodic table. In order to make the periodic table more useful and accurate, a few improvements were made in Mendeleev's periodic table. After the discovery of the atomic number by Moseley in 1911, it was noticed that elements could be classified more satisfactorily by using their atomic numbers rather than their atomic masses. Hence, the periodic table was improved by arranging the elements in ascending order of their atomic numbers instead of their atomic masses. This improvement rectified a number of confusions present in the old periodic table. The modern periodic table law states that if the elements are arranged in ascending order of their atomic numbers, their chemical properties repeat in a periodic manner. Another improvement was the addition of an extra group, Group 8A, at the extreme right of the periodic table. This group contains noble gases, which had not yet been discovered in Mendeleev's time. Another confusion in Mendeleev's table was that the elements like beryllium, magnesium, calcium, strontium, barium, and zinc, cadmium, and mercury were placed in single vertical column, while according to the properties they belong to two different categories. The same was true for so many other elements placed in same vertical group. In modern periodic table, the confusion was removed by dividing the elements in two types of vertical groups, A and B. In modern periodic table, beryllium, magnesium, calcium, strontium and barium are placed in group 2A, and zinc, cadmium and mercury are placed in group 2B.